Yo, what's up? This is Danny, and you may have came here from the other linked list video that we had showing you how to make one in Java without using the uh, linked list class. So, if this should be before the actual explanation. So I'm going to show you guys what a linked list, like how you can visually represent it. So in a linked list, there are a bunch of nodes, right? So each of these nodes has different information, so let's represent those using rectangles, right? And so each of those will have some sort of information in it. So I don't know. Let's say that it contains shapes or something like that, right? So that's what that is. And a linked list, if you want to think about like this, when you're using them, you're accessing the addresses. So for instance, this first node here, I want to write H in here because it's going to be the head node, the very beginning node. It will point to the next node, which will be here, right? So this is pointing to this address, and that address contains data. So when you're manipulating nodes, you're manipulating addresses which contain data, or in some cases, the actual data itself. So that will point there, and let's say this is the end. It will point to, maybe it will point to null, right? So that's the end of the list. So when this is like a basic linked list right here, and you can put whatever data you want in it, because the linked list, if you're using it just sets it as elements, which means you're allowed to put whatever types of data you want in there. If you want a bunch of data in there, you can too. That's why you use the class structure. Um, okay, so this is a basic linked list. Sometimes you want to use a doubly linked list or a circularly linked list. So if we have a uh, doubly linked list, it means that the linked list is pointing forwards and backwards. So not only does head point to the next one, it also points backwards. And so instead of using an accessor node called .next, you'd use .previous. And then if you use a doubly, then instead of this right here pointing to null, this will point back to head. So it'll go like this, right? So sometimes I think circularly is sometimes useful, but definitely the most useful out of all of them uh, is the doubly linked list. And the reason for that is when you're sorting through something or searching through data that's more than just finding a max or a min or finding in like alphabetical order, then you want to quickly go back and forth and doing sorts and stuff like that. Is it becomes much easier because otherwise you have to keep making a variable that stores the data beforehand, right? So uh, an example of, let's say, editing the node, if you want to delete, let's say we want to delete the middle node, right? So this is pointing to this and this is pointing to this. So what we do is we remove this node, right? So now we have this points to a null node, nothing points to this node, and this still pointing to head. We'll keep it circularly. So now all you do, like visually, all you do is you just kind of change that from pointing to this empty box to pointing to down here, right? So similar thing with like switching nodes, right? Let's say we keep it physically the same. Then what you can do, what you can do is change this address to here and this to here. So when I'm visually drawing this out, this is in order right now, but if you don't, like technically, um, because there's no actual visual representation, what you can do is even, or what it would kind of look like is this. I use a pencil now. This will point to this. This will point back to this. This will point to this, and now, I'm sorry, this will point to this, and this will also point back. Holy moly, that's ugly. Might be. this will not point to this, and this will point back, and now this will point to this, right? So this is why we usually don't use visual representations, because if you're not moving the stuff around, technically I would want to move this node over here, but because we're moving addresses, I just wanted to show you guys what it would look like if you were just strictly moving addresses. It can get really messy, and that's why it's important to grasp this visually first, because um, if you don't recognize that it's pointing to addresses, then it's weird, because when you're editing in the linked list, you're editing current, and if you like, current's not the same thing as the exact node, right? It's just a value equal to it, and that's why you have to understand that it's addresses. Um, the actual node and current is a representation of the node because it takes the same data address rather than taking the same data. So yeah, that's what a linked list basically is. I'll also explain by binary trees. So binary trees are similar, whereas the linked list goes kind of straight in terms of visual. Binary trees start with this, and this is called the root node, and then they sort left to right. So let's say this value was 3, and you wanted to insert node 2, or now let's do 1, then it would do its algorithm and go to the left and add 2 or 1. Yeah. So same thing, if you want to add 4, uh, then 4 would go on the right, like this. And now if you add in 2, 2 is less than 3, and now it checks this is greater than 1. So then it adds this. So it's kind of more top-down visually. And they're... Jesus. And there's a similar style where you can do like the previous. There's no such thing as circularly, of course, because you can't attach a bunch of nodes together like this in a circle without making it a linked list again. So binary trees are good for it makes it really easy to sort data, because you create an algorithm that already sorts it. And that's why usually when you're making a data structure, you're gonna make it a binary tree rather than just a straight linked list if it's more complex. Um, and so it also makes recursion super easy. So yeah, that's what a linked list and binary trees visually are like. So thanks for watching. I know it's a little messy, but now you can go back to the other video and learn to code it.